I understand that completely.
What is the what are the your percentages on your A and B? Is it a regular like medical course where it's 92 is an A and
Oh,
91 is a B, or is it
in this course?
Yeah.
No.
is it 90 and above is an A?
Yeah.
Okay.
Yeah.
So I know some of them where it's like you have to have a 91 to have an A, and a 90 isn't actually a B.
Yeah, no, if you look at the course guide,
Okay.
it goes over that.
Oh, I looked at the schedule too, the one you told us to go to, and the CPR class is not on there.
Oh, you're right, it isn't. I forgot that. When is that?
Is it still on the 17th?
November 17th.
Yeah.
November. Okay.
Forgot all about that.
Tomorrow? Oh,
No, November.
She said I had to
Oh,
go.
man. My brain's not all there today.
Okay. We're all with you.
That's why it's like my third cup of coffee today.
I need probably an extra one. Try to remember to put that in. So you guys know Mind Tap chapter 8's due tomorrow. Okay.
I actually made the mistake, and for some reason I read Sunday, so I had it.
You went ahead and did it?
I went ahead and did it like Saturday night, so I'm like, then it pops up. I'm like, oh, I guess I'm okay then.
Yep. Let's see. So the 17th, you said the 17th of November, huh? It's on a Friday?
Yes.
Okay. I guess that's why I forgot. I guess that sounds like a good excuse, huh?
It's there, take it.
Yeah. Okay. You guys don't have any questions about the schedule for class? Anything?
So,
Is this test tomorrow?
Thursday.
Thursday?
Right?
Chapter
No,
6.
Wednesday.
Chapter 6?
It's tomorrow.
Chapter 6.
It is
on the
tomorrow,
calendar
isn't
says
it?
tomorrow. The calendar
Yes, it
says
is.
tomorrow.
I don't know, even know. Yes, I did print it out. Okay. Yes, it is tomorrow.
And what is the chapter 8 one?
Isn't that on Wednesday?
The 23rd.
The 23rd.
So
Next-
week
next
is
Monday.
That's next week.
Is that
Oh, it's
Monday?
next week. Okay, it is. Oh, okay, I see what you're saying.
Yeah, so
18th we have the review.
we'll take that test and then we'll start with the chapter 9 after that presentation. So I'll try to get those to you quickly so you guys have time to work on them. Okay.
So tomorrow is.
So any questions off the top of your head about any of this chapter so far?
Do they do telesurgery anywhere near here or no?
Yeah, Durango.
Oh, in Durango?
Mhm.
That's awesome.
Yeah, at Mercy, they do it, I think GYN, maybe some urology. And that's at Mercy. And then at Ash, they have started doing some there too. So not telesurgery, sorry,
Oh,
robotics.
robotic. Okay.
Telesurgery. none
Probably
that I
not.
know.
When would Equinize come
When would they be used?
for laser? Where is it somewhere?
Which number is that?
When was ebonized instruments used?
Wouldn't it be when a surgical laser is being used?
Yes.
A surgical laser is being used?
Yeah, so basically during laser surgery. Remember, because the laser beam can reflect off of instruments, anything reflective. So what are some popular search engines that you guys know? Yeah.
Google, Yahoo.
It used to be Bing, wasn't
Yeah.
that? Is it still being used?
Bing
I don't know.
Bing.
it is one. Yeah, it's
Yeah.
not as popular.
Yeah.
as it
Anymore.
is,
Yeah.
But yeah.
Yeah, Google, what else do people use? Like real common. Safari, I guess?
Yeah.
Safari's one.
Yeah.
Yeah, Safari's one.
So what are some different parts of the computer? Hardware, yeah. The monitor, this thing here. The keypad.
It's a mouse.
Yes, this with the tail,
The
right?
clicky thing.
The clicking thing.
The clicky thing. So how much is in a gigabyte?
1,024 megabytes.
So how do you save files?
How do you say
Or
it?
on the file function.
Click save.
Click save. Right click and save.
How
and
about
then
if you were to
save
put it on a
as.
disk?
Save as.
Save as.
No. What is it called when you do that? If you were going to put, let's say you're putting
File
some music on a
Like
disc.
burning it?
Yes,
Oh,
burn.
Oh.
Burning.
What's the correct answer though?
Bernie.
I think burn. But you guys know that, right?
Right.
If you've seen it, you'd be like, oh, I know what that is.
Oh, but like, I just thought it was like to save a document, like, I want
You
to
said
save
that sounds
Word.
like
Click.
save.
I know,
like-
file, save.
Remember old school, this chapter is kind
Floppy
of old-ish.
Yeah.
Yeah, floppy disk.
Oh my God.
What else?
Remember floppy disks when we were kids at school?
Yeah.
What kind of floppy disk? What's the first floppy disk you ever saw?
The one with plastic in the middle.
Black.
Yes,
Yeah.
okay, good. I'm not that bad. I'm just,
How
yeah, it's like
old?
big 5 1/4.
Or,
My dad did
so
all
like
kinds of computers.
VHS tapes.
Yeah,
How about cassettes? You guys remember cassettes?
yeah. Wind
No.
it with your eraser.
What?
You rewind it with your eraser.
Gosh.
Oh,
I
that's
used to have some.
I still
How about
have
an
it somewhere.
8-track?
I've seen one. I didn't use it.
Have you seen
Track?
one?
Yeah.
My parents had one and I played with the 8-track.
Yeah, it's funny.
Or a
You think
record
back.
player. Those are fun.
Yeah, record players. How do you see a screen image? How is it seen clearly?
Resolution, adjusting resolution.
Right, the resolution. So you guys understand the computer stuff. I don't think there's really anything in there that you don't know.
What was it, gigabyte?
1,000 megabytes?
24 megabytes.
Right, yeah. So
1,000 megabytes to
1,024 to be precise.
Somewhere in here.
A gigabyte's a billion.
A billion?
Yeah, so it's a
What
billion
about a
bytes.
terabyte?
Terabyte's a trillion.
There you go.
I'm wanting to get one of those jump drive with a terabyte of memory. I'm like, holy smokes, how much that is.
So as you guys can imagine, now in operating rooms and CS, they use computers. Operating rooms, they do the patient's chart. They can look up their records. It's nice because, I mean, when I started in the OR, which really wasn't that long ago, 15 years ago or so, they didn't have computer. They didn't do computer charting in the OR, and now they do. So that's how, how fast I feel like we're advancing. So everything that has to do with that goes on with the surgical procedure can be seen on the computer in the OR. They can bring up lab results, any x-rays, any kind of stuff that instructions that they've had done, they can bring them up on the computer, which is really handy because it used to be surgeons standing around waiting for somebody to bring films in these big envelopes, and they'd put them up on the wall. Look at them, you know, and they don't need that anymore. And it's instant. You know, once they take a picture, the surgeon can see it just within a few minutes or a few seconds, really. Sterile processing can keep track of what's in trays, where trays are at, who needs what trays. So it's made life so much easier for doing everything in the operating room. And then there's electricity. I had found a little video on electricity. I thought, oh, that's kind of explains it a little bit. It's funny, you can look at something on your computer in your office and then come and look at it here. It's totally different. That's what I'll come up with that one.
Powers our home.
We'll see how this one is. I didn't watch this one. I watched a different one.
Here's a question for you. How many people does it take to turn on a light bulb? The answer seems simple. Just walk into a dark room, flip a switch, and instantly you can see, right? Well, the truth is there's a lot more to generating and delivering electrical power than you probably imagined. Hi, I'm Lee Patrick Sullivan with Energy Now, and this Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal, oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft, which spins magnets with a coil inside a generator. It's the generator inside the turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states. Transporting electricity from the power plant to your home is an entirely different process. Current technology cannot cost-effectively store large amounts of electricity, so significant challenges exist when it comes to transferring that electricity across long distances. Just enough electricity has to be generated to meet demand at all times and be transmitted through power lines to reach your light switch. Too much or too little power can crash the transmission system and cause a blackout. That's why a complex mix of logistics, management, and infrastructure is needed to transmit electricity from power generators to consumers. Enter the electricity grid, also known as simply the grid. The North American electricity grid is actually made of 4 large grid systems: the Western grid, the Eastern grid, the Texas grid, and a grid covering the Canadian province of Quebec. These independent regional networks of power plants and transmission lines carry electric energy at high voltage within their area to local utilities. There are very limited links between the 4 grids, which means electricity generated from a wind turbine in West Texas cannot reach an apartment building in New York City. For electricity to move through one of the 4 grids, its voltage must first be increased by a device called a transformer. Then the electricity can travel long distances across high voltage transmission lines. These high voltage lines are generally strung between giant metal towers. They stretch for miles from power plants to local substations in each neighborhood. You've probably seen substations along the side of the road and wonder what they do. Well, their job is stepping down electric voltages from levels as high as 765,000 volts closer to the 110 volts you use in your home. The electricity from the power line on your street passes through another transformer, which steps down the voltage once more, and then it travels along the line into your house. From there, the electricity enters your breaker box, and it is then distributed to light sockets and outlets. All you have to do is flip a switch. So, as you can see, from the raw materials to the power lines on your street, there's so much more to the electricity ecosystem than meets the eye.
Animation on that was nice.
Yeah. Oops. All right, if I can get out of here now, there we go.
Let's suppose that you're ready.
Okay. Now you guys know a little bit more about electricity and how it's generated. Ron, you worked with electricity, didn't you?
Yeah, I worked at
The power plant?
E&M and
APS?
APS power plants
So Ron could have told us.
and both mines.
Yeah. So now we know where the name Bovee came from, right? W.T. Bovee. He developed the first spark gap tube generator, and that was electrosurgical generator, now commonly used in surgery. And we think of it as Bovee or ESU. And then there's a bunch of stuff about electrons. Do you guys understand electrons. The term electricity describes the free electrons moving or flowing from the ring of one atom to another. That's basically how AC/DC flows, and it flows using electrons. They got to be negative and positive. That other video I had found was better. Showed the difference between negative and positive. So what's the spark gap generator?
Is it just talking about the generator?
It's just basically the ESU, electrosurgical unit. As long as you know that or Bovie, you should know. What are charged ends of a magnet?
Negative, positive.
Yes. Volts is the term, defines electrical potential. And that's what moves electricity from one point to another.
So that's volts.
Mm-hmm. What's the common voltage to run? Think of bigger equipment in the OR.
110.
220.
110 is like household.
Yeah, household. So bigger equipment is 220.
Most welders are 220, aren't they?
Big welders are 220. Even like some of your washer and dryers in your house, those can be 220.
Your dryer is normally
220.
Your dryer will
So you, at your house, you have a dedicated 220 circuit.
Yeah, you've got to have a special plug put in.
Yeah. That's the one that my electrician won't mess with.
Oh yeah.
Otherwise, a 110, he leaves it on to repair it.
Oh.
He says it doesn't hurt that bad.
Yeah.
Okay, Terry.
You're used to it, huh?
He says he got used to it, so he says 220 I'll turn off, 110 I'll leave on. It's not that bad. Okay.
So under wall outlets on page 109, it says the wall outlets in the OR are usually 110 for just running typical equipment, but big equipment like x-rays and things like that need the 220. Let's see, the cycle of AC, let me see, direct current and alternating current, which is AC/DC. The cycle represents one AC cycle called a hertz. I think that must be a question. Don't see it.
We have how does AC/DC flow and how is it measured?
And then our
Our
radio
radio
waves.
So how are radio waves measured?
And the cycle equals 1 hertz.
And per second is a frequency.
Mm-hmm.
Right. So frequency, when you think about tuning an old AM, you always want, to me, it reminds me of AM radio frequency. That's the radio waves. So what's a bipolar, and what's the difference between using that instead of an ESU? Right, and what
Bipolar
else?
has 2 active leads, right?
And it eliminates the use of the grounding pad
Yes, how come?
because it has the 2 prongs have the active and inactive electrodes.
That's what Ron was saying. So no, that's okay. So when you use it, the current stays in between those 2 prongs, and it doesn't travel through the patient. So what are some reasons that we might be at risk for electrical shock during the procedure?
Damaged installations.
Yeah, damaged insulation would be a big one. Yeah. So if you're using a Bovie or even a bipolar, if some of the stuff that's on it, some of the plastic that insulates it is off and you accidentally put your finger there, you could get burned or electrocuted.
Have you been burned yourself?
I haven't been burned. I've seen surgeons who've burned themselves because a lot of times they put their fingers really close to the Bovie. When they're Bovieing things, they'll use their finger to like kind of like to guide, and so their fingers just right there. So, and I think it hurts because they say a lot of bad words.
Hit the OR table with it or anything? Like arc out?
No, No, and mainly because you've got to push the button to, to activate it. So yeah, I've seen that happen. And I know it talks in the chapter about them. Sometimes they'll use a hemostat and ask you to touch that hemostat. You're best if you can touch underneath their fingers, but it's hard. It kind of depends on where they're holding it at, but they'll want you to cauterize and they'll just touch something and they'll say, touch it. And so you touch it. I haven't seen them get burned like that, but it can happen. If their fingers. Uh-huh. Yeah, they just put the hemostat on something. And they do a few little things like that. Sometimes, like when they're doing laparoscopic procedures, if they've got a metal, just a metal prong on something that they're using, could be anything, just something grasping something. If they got a metal prong on that, they'll get the Bovie and just touch that, just to cauterize whatever it is. Instead of getting like harmonic or something, they need to just get that bleeder right then. They'll just touch the tip of that. So it works like that too.
Why wouldn't they just use the tip?
Laparoscopic.
Yeah.
Yeah, so when they're down in there and they're dissecting and something starts bleeding,
That makes sense.
yeah, they have cords that they can plug
I
into,
was visualizing more superficial.
and they have a cord that basically will produce electricity for them if they want to use that. Some doctors always use that cord and others, they just use harmonic, so it just kind of depends. What are some types of ESU tips?
Blade-shaped, ball tip, loop, needle, and long extended.
Yep, needle. Yep. How can we be safe when using ESU?
Sure you're grounded.
Let the surgeon
Make sure you
use
put
it.
it back in the holster.
Make sure you put it in your holster, yeah.
Double glove.
Double gloving helps too. It
Keep
does.
this from getting shot. And then make sure.
The rubber's not exactly the best conductor of electricity.
Yeah. But, sometimes the Bovie, it ends up wherever. If you push on it and it's between you and the patient, it could burn both of you. So, but you need to be careful. So yeah, use your holster whenever possible. I usually, if I didn't clip it on the drape on the patient, I put it on my Mayo stand. I tuck it under somewhere and throw it in there. The surgeon's using it back and forth a lot, and they do, then they don't even want you to use that. Sometimes they'll get frustrated if you are using it and putting it in there every time they finish. They'll say, leave it alone, or they'll get that holster and they'll toss it. They'll say, you're not going to use it anymore. They toss it across the room. Like, I hate that thing. Okay. What's a proper placement of a patient electrode, return electrode?
Large fleshy area.
Yep. So large, fleshy area.
Flat.
Flat.
So no bony or like even like the butt cheek. Because you can have uneven attachment.
Yeah, some are more uneven than others, huh?
And closest to.
And closest to the, yeah. So there's a gel substance. You guys have felt those pads, haven't you? And that supports the conductivity of the current from the patient back to the generator, and it allows the pad to stick to the patient without damaging their skin. So that's why they ask you not to move it. If you have to move that Bovie pad, it's better just to get a new one. They might not work.
Does that say have to be shaved as well?
If they're really hairy, then yes. If they got like really hairy legs, then they need to shave that spot. And you're not going to see that often for the Bovie pad. But yeah, I mean, if they come in and they're like a gorilla, you're probably going to have to be shaved. It's going to hurt when that comes off too.
Well, I was just thinking of like the AED pad.
Yeah.
You know.
Yeah, it's probably kind of painful if you got a lot of hair. Let's see. I highlighted this, so I'm not really sure. It must be a question. Electrocardiogram electrodes have metal tips that can serve as an errant pathway for the current traveling to a ground, burning the patient. So careful placement of the electrodes is necessary. We already talked about the bipolar. It's got the two prongs, eliminating the need for a grounding pad. The current flows from the generator to the active electrode. That's one prong of the forceps. And the active electrode delivers the coagulating current to the surgical site. And the electrical current passes through the tissue between the tips of the forceps, and the current returns to the generator. So basically what we talked about, that the current just stays in between those two tips, and it only touches the tissue that's meant to touch.
And then it's going to be forceps.
Forceps type, yes. Bipolar, yes. Yeah, I can't think of anything else that's bipolar other than those.
Is
You
that
guys,
what it refers to? Bipolar is the two prongs? I was thinking about it this morning and I was like, aha.
Yeah.
I was wondering, well, I was thinking about the current, you know, bipolar two-way current versus one-way
monopolar. Yeah.
but and then it
Yeah, and if you just think about it, have you guys seen some bipolar forceps? Does Delco do any?
Not yet.
No. They're insulated. Usually, yeah, always. Well, I mean, there are. No, I was thinking of something else. Let me look. So those are what bipolars look like. So they plug in to a cord that's not usually disposable, and these are not disposable. And they're almost always angled because they're doing like neurosurgery, ENT might use just anywhere where you can think of the space is smaller, and they need to be able to look over them when they're cauterizing. So that's why they're like that.
All kinds of different shapes for everything.
Yeah, and these are the ones that you see most often. Like I have not seen these, and I haven't seen those. The tweezer type, I haven't seen those.
So when it's saying bipolar, one tweezer is negative, one tweezer is positive, and it curve jumps to the other.
Yep, it goes to, yeah, and it's staying in between. Because the positive and negative attract each other. It says opposites attract. Remember that. Because if it's two negatives or two positives, it won't do anything. So some electricity uses in the OR environment. We're going to see X-ray machines, endoscopes, robotics, lasers. What is laser?
Like
Light
amplification
something
by the
radiation.
simulated emission of radiation.
Right. Light amplification by the stimulated emission of radiation. This refers to the process of converting some form of energy into light energy that extends from the near ultraviolet portion to the far infrared portion of the electromagnetic spectrum. Laser is interesting. I really haven't worked with it. But the difference in the color of the light is a difference in what it can work on in tissues. It's monochromatic, which means that the photons that compose the light are all of the same color or wavelength. And its color is going to decide, just like I was saying, how it's going to react with various tissues. Fluence refers to the precision of the laser beam and consists of three properties: spot size, watts, and time. So that's how precision is measured, right? By fluence. So when laser beam contacts the tissue, there are 4 interactions that can occur: absorption, transmission, reflection, or scattering. So that's how it reacts to tissue, okay?
What was that again?
Absorption, transmission, reflection, or scattering. And that's there on 114 under the 4 interactions. A little farther, specular reflection is when the angle of the reflection is equal to the angle of the oncoming light, thus maintaining the beam. This type of reflection is used when the beam is reflected off a laser mirror to direct it toward hard-to-reach tissue, and that's why mirrors come in handy. In hard to reach tissue.
They have to like, I don't know, it just seems like it wouldn't be very accurate. They'd be like hitting something and have to adjust the beam till it gets to the spot they want. Just burn the big old arc.
And I think laser is probably more accurate than anything. Yeah, as long as you've got that the reflection correct.
Right.
So
how do they know they're correct before they hit it with the laser? Do they use light first?
maybe,
The laser is light,
maybe
right?
so.
I know, but you don't want to be burning something.
Right.
aimed at it.
Right. I'm sure there's a way they can adjust them before they actually use them.
Mhm.
There's probably a way, like setting up a scope where you set it just right at the target.
Right.
It says mirrors are positioned at both ends of the laser head. The laser energy is reflected off these mirrors. The mirror at one end of the laser head is completely reflective, and the mirror at the other end is partially reflective, which allows the laser light to exit as it narrows, as a narrow beam that is focused by a lens or passes into the delivery system. Some active media is there on table 6.6 on 115. So gas. So those are carbon dioxide, helium, neon, krypton, argon, and xenon. Solid, UV, and Nd:YAG. We'll go over that, and I always just see it referred to as Nd:YAG.
see the term, the neodymium, yttrium, aluminum, carbonate.
There you go. Yeah, that's why I don't remember the name of it, because it's a tough one. Liquid. And then semiconductor crystals. Those are active media. And then CO2 laser. The beam is invisible and is located in the middle of the infrared region of the electromagnetic spectrum. Because the beam is invisible, a helium neon laser beam is transmitted with CO2 laser beam to aid the surgeon in aiming.
It's always nice.
Yeah, that's a good thing.
Maybe that's what they-
Like Ron was saying, what
How
if
do we
they
find this? Fire
Let me
all
guess.
times.
Right.
That's not it.
says it had the helium neon beam has no effect on the tissue. So an advantage of using CO2 laser is that it permits precise cutting and coagulating due to the absorption of energy by the cellular water content. So absorption is not dependent upon tissue color or consistency. So that CO2 is not dependent on color.
I have a question.
Mhm.
Are these lasers, are they common? Or is I mean, because all I hear is about the Bowie. This method seems less damaging, there's less plume, it just seems overall like a better.
There's good and bad in it. Yeah. You've got to use a lot of protective equipment when using it. And it is common. I wouldn't say it's real common around here, but it's common that they use it. You got to you got to wear special eye protection when lasers in use. Things just have to be done special with the patient. I know it talks a little bit further in here how they'll use like maybe laps, some moist laps to protect the other tissue.
Okay, so I didn't mean the laser, I meant like the harmonic scalpel.
Harmonic's very common.
And, yeah, because it was just, you don't need the grounding pad.
Right.
It's all around, just seems safer. I mean, I'm sure like recovery time is faster also.
Yeah, I don't know how I think harmonic has affected recovery time because it makes the procedure faster. You guys remember when, when he came in and showed you guys harmonic?
Yeah.
Yeah, and they use harmonic for almost all laparoscopic procedures. There's different types of harmonic. We use like harmonic scalpel for lap choles, just different. But when they do GYN, they use a different type of harmonic. It's still harmonic, but it's harmonic.
And the argon gas too is the same.
Argon gas is for the laser.
Yeah,
It's wet.
It's for the argon laser, right?
yeah.
It's ESU.
ESU?
Yeah, it's inert vehicle combustion. More conductive, less tissue damage, less plume. I don't know, I didn't write the page number on it, but it's around the bipolar.
They use it as shielding gas?
My take on it is that argon, where did I write that? Let me find it here real quick.
I was just wondering, that's okay.
It enhances ESU, so it's not ESU, it helps,
Right.
right?
It's on page 113. And you make accessories to elective surgery.
Oh, yeah.
So CO2 is not effective for use if laser light needs to be transmitted through clear fluids. So if it's clear, there's clear fluids, it's not effective, it says. CO2 and helium neon beams are delivered through an articulated arm that is a hollow tube. Mirrors are positioned inside the tube at the articulation points or joints, and the beams are reflected off the mirrors down the tube. So when it's being transported to the OR, a person would need to be very careful to prevent an arm from hitting the walls or anything else so it doesn't disrupt the alignment of the beam. Sounds like something you'd want to put in the OR and not move.
Or you want to be the only one that's able to set it up.
Yeah. Yep.
That's what you're special.
Yeah. I'm sure where they use them, they probably have a room that's designated for that, and they're not moving it back and forth. Excimer laser uses gases and halogens as an active medium. The laser beam is ultraviolet in color, and it's absorbed by protein with minimal thermal spread. Problem with excimer? It's very toxic and can be fatal. The gas.
So, is there more than one laser that can be used in clear fluids and which is not dependent on tissue?
Yes.
Argon and the holmium together.
And krypton also, I think. Well, it says it requires water to cool the system. So they use krypton on ophthalmic procedures. And they do talk about lasers and endoscopy. So when they do EGDs, so you guys understand endoscopy is like EGDs, colonoscopies, things that go in natural openings. Okay, so the mouth, anus, things like that. That's what endoscopy is. It says arthroscopy occasionally uses YAG. I haven't seen them use it. But you never know by the, within another year or two, they might be really common just because they're more precise and probably make the procedure go by faster.
So if they're using lasers and endoscope and microscope type cases, you still have to wear all your safety equipment.
I would think you would still have to wear all that safety equipment. They put up usually a special sign on the door if lasers in use. For anybody walking in, they need to make sure to have special eye protection on, because it can make you go blind. I think we covered all the questions there under with laser. So, surgical robots. What is a common name for the robotic system? Da Vinci, yeah. I guess they've come out with different ones. Different companies have come out with different ones, but Da Vinci is the most common. Hopefully at some point maybe we can go to Mercy and you guys can go see the robotic system. Robotics is interesting. I still have a hard time believing that it's the way to go.
So I was reading that it kind of said that the surgeon could be in a different place than the actual.
Telesurgeon.
What happens if like an emergency happens? Is there other doctors on stand in that room?
Oh yeah, there's
watching?
people there.
Yeah, so the surgeon would more than likely either have another surgeon there. Most likely it's going to be another surgeon. They could have like a PA or first assistant there, but a surgeon would have to be on standby. Yeah, that I've never seen. That would be really interesting to see. Yeah. Yeah. As the patient, it would be kind of scary knowing that your surgeon's in New York and you're in California.
Mm-hmm.
So I don't know how often they use that, how popular it is. I've only heard about it. So usually the surgeon's sitting in the room, like on that picture on 119. The surgeon's the one sitting at that computer. The surgical tech that was working with robotics in Durango, she went through the whole setup, and how it is to get that robot ready for a surgical procedure. Seems like a lot of steps.
You have to drape a lot of stuff.
You do. Draping alone would be a nightmare. Everything else would probably not be that difficult. But you're going to be the one who's really responsible for moving things because the surgeon's sitting at the console. I don't know. I'm still like, I don't know. If I were to have surgery, if I'd want it done robotically. I mean, if the surgeon's in the room, they say it's more precise because if a surgeon has a slight, if they got a little movement in their hand, that can affect, if you're working on a brain or a heart, that little movement can make a big difference.
What about recognizing other ailments, though?
Oh, being able to see?
Yeah, robots are going to be like, oh, that doesn't look right.
Well, you're still seeing, the surgeon's still seeing everything. It's like laparoscopic, they still see everything. But instead of actually being up there and moving things, the robot's moving those
So it's not
things.
an independent robot yet. You're still
No.
getting input on it. But
Yeah.
you're saying fourth generation robots are going to be able to reproduce and think on their own and act on their own?
It's kind of scary.
You shouldn't put that in this book.
My question is, why are we doing this if that's what they're working on? Because they're gonna find robots to replace surgical techs
And surgeons.
and surgeons, and everybody's gonna.
Well, but the cost of robots is
No, right now.
millions. And I've asked them here if they think of ever getting robotics here, and I was told no, but I think it kind of depends. As the younger generation of surgeons comes, I think they'll, if they want them bad enough, they'll get it.
You got the 20 million to spend on them.
Yeah. Yep, and it's not just it's buying the initial robot. You have to maintain them, and it's very expensive. So I don't know.
Maybe as a tech in the future, you'll be maintaining a robot.
Mm-hmm. Well, the lady that was doing robotics in Durango, that's really what she was doing. She was going in. She'd have to go and work a little bit early to get it set up and to make sure everything's moving and just.
You know that you got to do monthly calibrations and.
I think they do calibrations on it every time they're going to use it. Yeah. Yeah. So it's quite a process. I don't know. My oldest sister had robotics surgery in Albuquerque for hysterectomy, I think it was. I mean, it went great, but she didn't know the difference whether it was robot or people, and you don't know the difference. It's trocars that go inside, just like a laparoscopic procedure. The only difference is the thing moving, making the cuts and everything, are arms on a robot, and the surgeon's sitting at his console. He's basically there with his joystick, like it's almost like a game. He's moving everything. Yeah. Yeah.
Very cool.
It is. It is pretty cool. So what's meant by degrees of freedom?
The number of ways the thing can move.
Yep. The arms can move. How about resolution of a robot?
The extent it can differentiate between two things.
Yeah. And where's the surgeon during robotic surgery? Console.
Console running it.
Yep. So like when the incisions are made for the trocars, the surgeons in there making those incisions, and then they go and they sit at the console. So anything done, that's making an incision, cutting, really the surgeon is responsible for all of those moves. So what does yaw mean?
The right and left
Yep.
movement.
Where is that?
It's on page 123, the second
Paragraph.
Yeah.
Up and down is known as a pitch. Right and left are called a yaw. And then a rotating is a roll. And you guys understand what telesurgery is? It's crazy.
Cool.
Yeah, it is. So how do they remain sterile?
They're not touching.
Huh?
That is what.
How does the robot remain sterile?
Would be, it's not sterilized, but are covered with special sterile sleeves. Would that be okay?
Yeah, so really it's all parts of it are draped. So there's this drape that goes on it.
So like the arm is draped, right?
Yep.
The actual part that's touching the patient is probably taken off, sterilized, and put back on.
Yeah, so like they're putting, of course, trocars, all of that is sterile. And the arm part that touches the patient is sterile. Sterile drapes. It's like basically like draping a microscope, but probably 10 times harder just because there's so many different arms. And you guys will get the experience of draping microscopes, and it's not fun, but you know, and it can kind of seem overwhelming when you do it, just because you've got this huge drape and you're trying to think, how am I going to keep this thing from not getting contaminated while I put all this on? But once you do it a few times, it's like no big deal. What's Cartesian coordinate?
System used for graphing and medical function.
Yep. And if you guys can believe it, that's the end of that chapter, which is crazy. It was such a short chapter. All right, so questions? How'd you guys do on the mind tap? Good.
Yeah.
Yeah.
First 15 questions were like,
The
okay.
case study, what computers.
Yeah, computer, okay. What's the first step? On switch.
I wonder if I left that in my office. I bet I did. Oh, I thought that was it. Oh, yeah, it is. So what two procedures would most likely require the use of a rigid endoscope?
Is there like a correct answer, or can we just pick two?
There is a correct, and I think I must have left it in my office. Yeah,
I
so
just got online and found two procedures.
Yeah.
so what did you come up with?
I did rigid nasal sinus and
Nasal sinuses.
and endoscopic third tracheostomy,
Yeah.
PTV, and RED.
I listed some of those.
Okay, and how about a flexible endoscope?
Those are the ones
Would that be
where
a
you
colonoscopy?
colonoscopy, into the mouth, things like that.
Yeah,
Anything you have to go around curves.
EGD. Yeah, think about things that are flexible.
Like I found more for the flexible ones, like
The rigid.
rigid.
Why does the light emitted by a laser create different results than a light emitted by an endoscope?
Laser is different than
Laser
normal light.
Yeah, laser light is different. It's monochromatic. It's
The light from an endoscope, you want it to spread out so you can see stuff.
Right.
And a laser, you're trying to be precise and cut something, not light up in there.
the laser is designed to the light that comes out of the laser is
One narrow.
focused in one. It doesn't
Pinpoint
spread
beam.
out. Pinpoints.
Yeah,
And the light from a laser is monochromatic. On visible light, you have all kinds of spectrum going on, so you can see it.
yep. So if you think about like car lights or just overall a bigger area, but laser is more precise, like pointing a gun with a laser beam. You want it to be precise to hit that deer, right? Did you get one?
No,
Not yet?
We didn't get one. We're going again this weekend.
Okay. Anything else?
is coherent. Light waves travel in the same direction and in phase with each other, increasing its amplitude and its power.
Doesn't laser reacts with certain types of tissue?
Yes. In basically certain types of tissue environments.
Right,
play a
and
part.
the color of it affects what kind of
Oh,
tissue
yeah.
it best interacts with it.
Mhm.
Red laser with
Red tissue.
red tissue, things like that.
Pink,
So
red.
kind of the same matching dye color.
And I think it's in diagnostic chapters that we get into laser more. So we'll really start getting into stuff, and hopefully it'll make more sense then. Yeah, that one's pretty short.
That's okay. I've previewed chapter 9. It's a long one.
9, and that's pharmacology.
That's a long 60, 70 pages.
The rest you read,
Oh yeah, chapter 9's a long one.
Wow.
Yeah.
Yeah, chapter 9's a big one.
Yeah, so enjoy when we have like these little short chapters, because pretty soon they're going to be huge and a lot, just so much information.
And you're only going over 6 chapters this part?
Probably. Yeah. Yeah, I think we went over, what, 7 or 8 maybe in the last one? 8. Yeah, and then we'll have 10 chapters left. And it's hard to get through 5 in one section. Because there's so much information. When we get to like all these different chapters, surgical chapters, I'll just keep telling you guys, there's so much information, there's no way you're ever going to remember all of it. It's tough. If you can just kind of remember the basics about the surgical procedures, when you do those procedures, you're going to go back and you're going to look at those chapters again and go over those procedures, because there's no way you would ever remember them. There's no way I remember them. The only way, that I would refresh myself, when you start doing things over and over, that's how you remember them. And here, in this area, we do things, a lot of the same things over and over. Lap choles, so many, you'll be able to do them in your sleep almost. Hernias, tonsils, ears, arthroscopies, all those types of things. You do so many of them. You guys will get so much experience at doing those things. And then when you move away and go to bigger hospitals and you're doing bigger cases like hearts, then you're going to learn those. Hearts, I don't know. Dell's worked with hearts. I never did. But from what I've heard, they're just monotonous. They're very long procedures, and I've heard they're boring. I think it would be exciting probably to do them for a while. And then after a while, you're like, okay, I've seen that.
What's your favorite type of procedure?
Well, I like general surgery because I like seeing the inside of everything. I didn't really like ortho, but I kind of at the end was starting to enjoy it a little bit more. But a lot of the orthopedic surgeons, they're always about they're about time. They want to hurry up. Come on, let's go. And you'll see it. You'll see what I mean. And I like general surgery because it's a little bit more laid back, and it's like, okay, they can't rush. They got to look through everything and check and make sure that everything is just, there's nothing bleeding. So I feel like they're just a little bit more laid back. Orthopedics, it's like, okay, we got 5 totals today. Let's go. Clock's ticking, and I don't like that. I don't like to be rushed. I like to really know about the case, to really see things. And with ortho, you don't really see things as much, I guess. Guys, you guys might like it because it's kind of like working in the shop on people. Cutting things.
Screwdriver. Nail gun.
Yeah. Yeah, screws and nuts and bolts and all kinds of stuff.
Right up our alley.
Yeah. Yeah. But there's some ladies that love it too. It just really depends. And you guys will kind of get an idea of what you really like. And, you know, Dell, I don't know if he's talked to you guys about when you guys start thinking about places that you want to work. Hospital's always the best place to work first because that's where you're going to get experience doing everything. Surgery centers, you know, they do limited things because ASH is growing. ASH is a animal surgical hospital, and that's growing, and they do more there because it is a surgical hospital, but they do mainly day procedures, you know, where people go home the same day, but they can stay there if they need to. But, you know,
Where's
they
that
don't
at?
do a whole lot of ASH is in Durango.
Durango.
Mm-hmm. So if you go to the mall, it's across the street, across the river, I guess. Yeah. But you guys will get to go to the different places and see what you really like. If you like really fast pace, just come on, let's get it done, then a surgery center. But if you want to really do cases that are really interesting, backs, brains, you know, anything where they got to make a big incision on a patient, then you'll want to be at a hospital.
What about like career advancement? If you do go to a surgical center, you still gonna have the opportunity to possibly be a first assistant or whatever. You just locked in
Possibly.
your position.
Possibly. And if we can get Dell on full time here at college, which I keep working at, I want him to start a first assist program here. You know, I think it would be really successful because right now most people go to Tennessee. They do, you and in a person that we do start a program here, you'd still do everything online. All your book stuff would be all online because it's mainly working with the surgeon is what you're doing. And then you're doing homework. But when you go and check off, kind of like lab, it would be here. And that's what Dell would do.
Be able to do the online section with the Gordo students too, possibly.
Mm-hmm. Yeah.
So if we live in a different town.
Oh, yeah.
we could do the same.
Yeah, and I mean, for anybody who lives in the western part of the United States, they would want to come here because right now they got to travel to Tennessee. Most people. And it just depends. I mean, accreditation, not accredited, you know, or a different accreditation. And most people recognize the accreditation that we have, which is KHEF, and so with that program. But yeah, just, you know, when we start going over these chapters, we're going to do our best for you guys to understand the procedures or to at least know why people go to the hospital to have those surgical procedures. But all the stuff that goes along with it, there's just no way you're going to ever remember it. You won't. You'll remember more or less about when you hear it. You'll be like, oh yeah, that was surgery on this, you know. But many, many times I'd see a procedure on the board at the hospital and I was in that room and I'd be like, what is it? And I'd go look and do research on the procedure. And then I would feel better about it. Oh, okay, well I can do that. Basically just making an incision and this is what we're going for. But yeah, we'll start getting to those. But yeah, chapter 9 is pharmacology it's huge. There's so many drugs out there. Good thing in the OR, we only deal with kind of a limited amount of drugs on our field. And those are the ones that you guys really will need to learn and to remember, you know, the importance of all those drugs.
We don't need that little extra pharmacology book.
No. I have probably 5 pharmacology books in my office. And for a time, I did get a pharmacology book in the classroom, and I just thought, no, there's way too much information in that book. We can bring things into the classroom about pharmacology. If I can, I would like to see if a anesthesiologist could come here and give a talk about anesthesia, because that's the most fascinating part of pharmacology. Yeah. Yeah, we've had one that's come before and she was awesome. So I'll check and see if maybe she can do that again. Yeah. All right. So you guys are ready for the test?
Yes.
Okay.
We're good.
Get it done. Okay.
It's a chance to review it, and we're good.
If you think of any questions you have about anything, just email me.
Will we be doing a CST exam?
Probably not today. Okay, probably tomorrow. So in lab, I'm planning on coming in here tomorrow. And so we'll do the half and half. I'll be here. Last week I came in here and you guys were in the lab and I thought I'll just leave you in the lab with Dale. But yes, we will continue that. There's just nothing new today. Okay?
The questions that we've been given in terms of like the 6 pointers, and they're going to be little quizzes.
Yeah.
Are those going to be?
Yeah,
So like the daily ones, those you'll just be able to take it home. Okay?
Okay.
The one that, like for the week, that'll be given with your chapter test.
Okay.
Okay? So there won't be one with tomorrow's test because I haven't given you any questions.
So we will have one that's due this week.
Like a CST, like a little quiz. Yeah.
What time?
I usually try to open them like at, I don't know if I do 8 but I can open them anytime.
Because we only have
Right.
I do the same thing as the school schedule.
Oh, okay. Oh, okay. Well, remind me Thursday, and I'll open it for you Thursday so you can do it
Oh, okay.
Thursday morning.
Thursday. Yeah, okay. Thursday evening. All right,
Yeah,
cool.
okay.
Great.
Just remind
Bring
me.
up something similar. I'm going to be gone this weekend.
Yeah.
Yeah, that would happen. So if you have any CST exams or something like that, you might do it first.
Oh, yeah, you can. Yeah, so I'll just open them up for you guys. I don't think we have anything on the weekend, right? I think we're just doing these.
I was afraid we were going to be doing a mixed presentation or something this weekend.
Yeah.
No, you guys are going to start mixed presentations chapter 9 because that chapter's so huge.
Okay, so that's why we're doing the mixes is on chapter.
Yeah, there's several of them in this section, but yeah, no.
So pretty much set for this week.
There's 22, that's Sunday, right?
Yeah.
So I'll just make sure I'll have it.
Yeah. And if
Yeah,
for some
'cause I'm
reason
gonna have
it's
to do
not
the mind
open.
tap too before I leave because I won't be coming back until Sunday.
Yeah, I mean,
So I'm gonna have to do the mind tap and everything I need on Thursday.
Yeah.
So I'm done Friday because Friday, Saturday I'm gone.
I'm doing the same.
So if you did 8 already, just get in there and do 9.
Okay.
It should be open.
Okay. So I'm
If
that's
it's
it.
not, let me
So
know.
that's all we're doing is mind tap this week, for the most part.
Yeah,
Make
yeah.
sure I get 8 and 9 done.
Yeah,
All right,
8 and 9
8,
done.
9.
Yep, and then just test
8 is
on
done because
chapter 6 tomorrow.
I screwed up because I thought 8 was due on Sunday, so I did 8 last
Just ahead of the game.
And I'm like,
Yeah.
okay, so now I have to do 9.
Yeah, so you don't
Get
have as
chapter
much
9.
to do.
Oh, I have to figure out how to read chapter 9 though.
Your whole sections. Later.
Yeah, okay, we'll see.
Thank you.
All right. You guys remind me, okay? If there's something, just remind me on Thursday.
Okay, I'll do that. Thank you.
Okay,